All right, so in this video, let me give you a quick background. So this is an X79, Asus X79. This was the Intel 4930K Black Edition. But that's not really the point. Doesn't matter. It is an older, this is an older machine, and it is my daily driver. It's what we're on right now. And so she's working pretty good. It's been updated all the way along. We're going to go back to 2021 where I had some stability issues. You'll see in the video coming up a quick example of I'd boot it, it would boot, and then it would go boink, and it might even go into a cycle scenario where it would come up, and eventually it just would corrupt the OS or whatever, and you'd blue screen. And so these instability issues and hard drive burnouts, we're going back in time to 2021 in the summer, and that was a very hot summer. Sorry for the AC noise, heat, dirt, it's a shop, and I talk a little about that. So we're going to try to figure out what's going on. You're going to see a potential cable issue, and I replaced the power supply, put an EVGA, big ass power supply in here, and all these years later now. So this is April 8th, 2026. Let's get started. And let's see if she boots. Now, it actually booted in. Last night I did get it to boot twice, but then it would just go boink. And of course, Windows 10 is not happy when you do that. Okay, we got a login screen. Thermal instabilities are one thing, but it can also be a lot of other instabilities. So I'm just going to go real quick and try to find some of my files. Oh, there it goes. See? Now that's what it does. See, and here it comes. Right, and there it goes, and it starts to crap again. Right, and it'll just keep doing that. So let's just shut it down. Soft shut off. So I've connected my power supply tester. I want to give a shout out to my buddy Rob over in Arizona. He sent me one of these a while back because I was having some other issues. Okay, and if you can't see it, then you'll know. Press the on button. I have 12.4 volts on the negative 12 volt rail. But on the positive 12 volt rail, I'm getting an alarm, LL. So V1 is 12.1, but V2 is low. All right, so we have a problem with the power supply right off the bat. This is Seasonic 80 plus. I've had a lot of issues over the years with Seasonic. They were rated as very high, but I've never had one that really ever lasted. It's a 1050. So let's take this power supply out now, and we're going to do another bench test with it.
A few moments later.
All right, we got it up on the bench, and I got to tell you, trying to get this cable out, this motherboard cable out here, the main bundle, oh man, I had to use pliers to get that out. It would not come out. It's been in there for so long. Now, a lot of people don't like this type of interface, right? Because the interface can cause problems. I've actually had that problem. I've actually been in here and had a problem with another Seasonic, and it wasn't soldered right. And that was its problem. Then I had another one that burned out, and I couldn't get any satisfaction from Seasonic. So I won't be buying Seasonic anymore. This is the last one. So let's turn it on. Okay. Now this is just a fan switch. Same result. Now it'll come on. I thought it might have even been burned, but I'm going to open this up now. We're going to go in here. We're going to go look a little bit deeper. And worst case is I had to pick up another power supply. All right, now first look. I don't smell anything, but this is very discolored, right? Why is that so discolored? Could be one of these caps is bad. And you can see it's pretty dirty. It's been cleaned once or twice. You know, most of the caps are good quality. And see if it needs any soldering, which I don't think that's the problem. I think we have a weak cap or a burned out circuit. Okay, so you have V1, V2, V1 negative, V1 positive, V2 negative, V2 positive, right? So you got really 4 circuits, but 2 different supply systems on here, or rails. And it's weak. It's a low voltage.
Day 2.
I can tell you this thing's real heavy. Now this is more power supply than I need, and probably way more power supply than most people need. Typically for most systems, about 750 watts is all you need to 800 watts. And usually, you know, this is a little over $200 to my door, about 214. There's a few reasons for why I like expensive power supplies. One, they're just damn cool, right? There's nothing like, I mean, this is really like the power heart of the whole computer engine, as it were, you know, or body. I mean, maybe this, some might even say it's like the lifeblood, where this power is coursing through the veins. So I figured I would also recable the computer. I've run into some issues in the past. Here's an adapter, it looks like. So we're going to want to check everything. Again, this is about $200 as well. And you can see the difference in size, right? It's a huge difference. There's a good couple of inches of extended, you know, power supply area. This was also a gold power supply, and this was 1050 active PFC. I like the color and the anodizing that they put on it. So we have another adapter here. Okay, and then these are our powers. This is all of our CPU, motherboard, power system cables, and the rest are you know, for PCI and you know, hard drives and such. So we'll get to that in a bit. I see a lot of Molex connectors on here still. We have here a bunch of Molexers, and we also have over here, looks like SATA drive connectors. So we're going to go through that in a minute. Let's go set up on the other table, plug this thing in, and see what happens. It's all plugged in, so we're ready to go. Now, it has an eco mode on it over here, and you got the power switch on the back. Now, it's set to off. Now, what that is it allows the fan, when it's set to on, it allows the fan to cycle on when necessary. And generally, I like to mount it fan down, but you don't have to. You can mount it fan up. And I'll show you why when we get to the case in a minute. I actually have an opening I cut in my case, and I put a filter on it. Now, my shop is really, really dirty, so I'm going to be trying to convert things to basically run fanless as much as possible. Let me get the other power supply, and I want to show you something. Now, in the X series, okay, here, it has the same kind of switch, hybrid normal, they call it, all right? But it's actually on the inside of the case, which is really kind of stupid because then you got to take the case side door off. Depending upon what kind of case you have, that could be a real royal pain in the neck, especially depending on where you mount it. So in my scenario, I like this better. And most of the time, I don't want the fan running. Now, it gets real hot in the summertime, and so I'm going to want that fan running then. And I'll just have to deal with a little bit more maintenance. But we're in September. We're actually coming into the fall. This is the end of the summer. And so I'm going to probably leave this fan off. Now, there's another little benefit of why I can leave the fan off. This is a 1,000-watt power supply, so it's actually overrated for my application. And so if you want to kind of run something in an eco mode, you don't want to be at the edge of the power supply's capacity and then disable the fan and kind of crippling the cooling solution you have on the power supply. By overrating the power supply, I can pretty much guarantee that at any given time, right, it's ambient cooling is going to be more than enough. So that was another reason why I went with the 1,000-watt. You also get all the Japanese capacitors in here, right? You just get better components. Everything is just generally better. And EVGA is, they're highly rated. So you have a better construction in terms of the components used inside. It's able to deal with heat better, and it won't ever really get near its maximum output. Now, a lot of people don't like multi-rails. Corsair has, I think, one with a physical switch on it. That's what burned out on my last power supply, right? One of the rails burned out, and that can happen. Now, I don't know what's better or worse, really, in terms of a rail burning out. If it's all single rail and the single rail burns out, either way, your computer's not going to work. But there tends to be a bit more protection on multi-rails. As long as the rails are rated, I believe also Corsair has another power supply that you can change the rail system on it from software. Let's make sure the power is on. You ready? I hope it doesn't screw up. You guys want to see here? Take a look. Now I'm getting a beep on this one too. Why is that? But I'm getting a different beep. Let me see what it means. It's still giving me an LL, just like the last power supply. That's not good. So we may have something wrong. And it's also saying these are high over here on the PG. So this power supply may be bad. Okay, right out of the box. That would suck, huh? Now, I'm not going to connect any of this because this is from the old power supply. This one says CPU, so they're set up basically the same, so we get two of these. Now, I made my own connector to run all the way up to the top. But right now, we're going to use all of their power connectors, and this one here is split. So I'm going to stick it up here, and I'll show you in a minute where it goes on this motherboard. And we'll use the case power switch. Okay, so we have power, and I have a code of 67. That doesn't mean anything right now. And what we want to see is it gonna power cycle? It's okay. Now I have an AE. Now that's a common error code. We're just going to shove a video card in with no hard drives, and we'll see if she power cycles. So let's soft power down, and then we want to throw the switch. And make sure the lights go off on, I'll show you in the back here, the little E, and wait for that light to go off before you plug anything in. It may take a bit. There it goes. Now, working with the power supply plugged in, okay, I'm grounded, so I keep touching the chassis. All right, so now let me grab the video card, and we'll find the associated power connector for it. VGA. And these also have these little splits. Now, I'm not going to put all the screws in. I'm just going to put one screw in, just to make sure that the card itself is, chassis grounded, so we don't have any issues there. All right, so we're powering up. Typically, the fans will start on this, and then they'll shut down. We're stopped on 62. There's no hard drives in it. It's not power cycling. All right, so there's the power CPU board power right there. I'm aiming at there next to the RAM. And so far so good. It seems to be doing fine. Now normally it would be cycling by now, right? And you guys saw that in the video. So I say, okay, so I say at this point now, let me pull the video card back out. We're gonna power it down. I'm gonna turn my air conditioner on too. And I'll show you a little bit about what I'm doing as we go. And I'm gonna chase out all of the power connectors for the new ones. Now I'm going to use a peripheral cable to supply power to the Lee drive switch. So I removed the one that was there, and we're going to plumb this one down and out and around. And also, it's going to supply some power to the fans over there. Now, you might think, well, it's loading a lot on one cable, but not really, and I've never had an issue with it, and it's designed for this. Now, I don't know if you can see it, but two of those pins are burned, one in particular, and I'll show you in a little bit the connector that went to it. So we had a problem here. And what I did was I took a pipe cleaner, I put a little bit of brake cleaner on it and ran that in there. I'm going to blow with the air, and we're going to change out that wire. And here as well. So who knows when that started to happen, but yeah. One of the nice things about the Lee switch is it allows you to put all your wires in a nice neat way out of the way. This is just to hold up the card, so it's an anti-sag. I made that. out of, I don't know what. It's somewhat adjustable. I highly recommend it. One of the biggest problems video cards have is sagging. When they sag, the motherboard separates out, heat sinks start to pull off, the chips on the card start to overheat. Yeah, this causes a lot of problems. Solder joints start to, come apart. I added a 2.0 extension bracket on for like rudder pedals and things like that I have. And I think we're done here. Let's start it back up. We have the NVMe drives in there. I actually changed their position slightly, and I had to move the bracket on one of them around. It was installed wrong. They're kind of cheap, but they do work, these converter cards. Eventually, when I get a different motherboard, we won't have to use these. It's been started so many times and failed that I may have an issue with the OS as well. Let's power up the power supply. Now, pretty much everything is connected, save a couple of things, because things are a little bit different. And the wiring on the connectors is different, which is another reason why I always say go with the new wires. All right, so we got something going on. Recovery, right? So it's this enter to try again. So let's go back around to the BIOS. Uh-oh, error occurred. Great, we have a Samsung issue. Soft power down. And I want to check to make sure my connections are okay. Oh, see, RAID failed, Stripe failed. Uh-oh. That's a problem. It was working, it just failed.
A few moments later.
All right, we can clear that. But status is normal. Let's see if it boots. And so I have an issue with one of the RAID array SSDs. It's a Stripe, so it's RAID 0. Probably from banging on and off, right? So I can't start the operating system in RAID mode with the two SSDs as a Stripe. One of them is throwing an error. And this one, I finally was able to get restarted in safe mode. So it's a single SSD with RAID enabled, and we should be able to restart now. And because it was having some issues. So let's make sure that this starts. Now, another problem is with the X79 CPUs, the high-end one, is that you have to amp up a little bit of the voltage, otherwise it won't boot. Because it's just not, and sometimes it'll just blue screen out or freeze. So it looks like we're up and going. I'm going to work a little bit more and see if I can get the RAID array to come back, and if not, I'll have to rebuild it.
20 minutes later.
And I went in and had some dinner with my daughter and her boyfriend, and it's been about a half hour, and it was still running. So it's definitely something wrong with that power supply. I think there's also something wrong with that power supply tester, but everything is running good. I'm charging the batteries on my laser thermometer, and we'll do some just general temperature checks. And we'll be back in a little bit. It didn't want to boot straight into Windows, so I booted into safe mode. It's in safe mode, and these are actually some files that I really need to copy off real quick before I do anything else. I've been copying files for quite some time now. I even went and took a shower, right? So, you needed it, Arch. So this heatsink right here over the MOSFETs, 95 degrees. I get the heat pipe itself, 99 degrees. And this is the multiplexer, 96 degrees, RAM, 91. These are great coolers, Noctua. Look them up, check them out. They're just awesome. So temperatures are very good. Check that connector. But we'll do some overclocking another day. Yeah, I'm not seeing any heat issues though. It's kind of warm in here. I just turned the AC off. 85, 84. I don't know which drive is actually running, but they're about the same. Okay, it's almost done. All right, now I'm going to put the NVMe drives in. Now, what they do is they give you these rubber bands. They're basically just a type of a flat rubber band. Now this type of silicone rubber band, that one was fine, but in this one they broke right away, and the heatsink falls off. So I used some O-rings, just 2 O-rings, and carefully stretched them on there. It should be fine. All right, let's install those and we'll retest and finish up. Sorry for the noise again. The AC's on again. It's just really hot out. All right, so I'm booted into RAID. I show you that error. We're going to have to live with that for now. I just want to check to see if the NVMEs are home. All right, good. So video edit is an NVMe. Let me tidy it up a little bit more. I can't put the back on and the covers on yet because I still don't have this working. So I'm going to need to rig up something tomorrow and bring power over to that. It's, you know, some of it's old school legacy, and you know, if you're willing to live with that, it's okay. I'm going to shut it down, and we'll hopefully be back in a little bit. So far, so good. At least I was able to do the backups that I needed to do and recover a few things. And if I can have a little bit of time to settle in, we should be able to straighten everything out.
The next day.
So this is, again, from Seasonic. This is CPU power. And these are pretty much point to point, so that doesn't change. And these are PCIe. And the idea is to split that circuit up that I just did, because the Molex that goes to the motherboard, that supplies power a little bit to the circuitry in the area, mostly the fan circuit, and it will supply power to the motherboard for the regulators in that area. And so I've got that and fans, and I've got all those drives running off of that one circuit. Not too happy about that. So I think we're going to maybe take this one. We'll use that other CPU rail, and we'll bring this into a twin Molex, something like this, and we'll supply the drives. And then the motherboard fan circuit and those couple extra fans will be on a separate channel. Okay, so this is the 12 volt leads here. And this is probably 5 or whatever, or 3. I don't remember. Now, don't go by the colors per se, right? Because they've been changing them. But the negative has to be associated to the positive. It has to do with the return as part of this output circuit being paired to its voltage, whatever voltage that is. All right, so I just trim these things down. These are great. These are really small. Most people have use lineman pliers and everything. Basically, it's a smaller version of that, and it's just great for doing small wires. Like this is feels like 18 gauge. It might be 22. I don't remember. Just pinch this one in a little so it fits in there properly. Now, feels like it holds okay. Now, these are the only two we need, but I'm going to do all of them because it'll be a useful jumper for other things when I retire this power supply or this system or whatever it is that I do in the future. Molex is very useful for things like this. They're decent. It's an industry standard, and it's particularly useful for power circuits like this. Accessories. I figure out. So I cut this connector off. And this is for the Seasonic, just so we don't screw up. I'll rip that piece of tape off later. It's the opposite side. And so we want to take that into account. Okay? So it's the opposite of this. So you got to match them. Now I'm just going to go look real quick and see how it's set up and what I'm going to connect to on the computer, just so I have it fresh in my brain. So as you can see here, all right, so negative, negative. And now we should just be able to match up the color. It should click. All right, and we're going to go test it before I put the heat shrink on. Fan 1, that fan comes on. That fan is on. Oh, and those are the two blue. And then this is just a quick dress out here. So this is the cable right here. Comes down, I got an extra, ties in here. It's old legacy. And that white Molex right there. All right. Hold on. Got a few more things to do. All right, the last thing is an old XFI Sound Blaster card. It's actually old, but Windows 10 actually finds drivers for it, and that's going to go in. And that's it. All right, it works really well with Cakewalk. I have an older Cakewalk program just for bringing in some basic stuff. But I put this nice washable filter on from behind. Now you're not even going to see it because it's going to be up against the desk. But all these are in. Everything is good to go here. Yeah, it's completely washable. In fact, I put, because of the filth in here, I can't have anything that is not really filtered. I use Super Clean, believe it or not. Gets all the grease off and the junk, and I wash it with the hose or in the sink. And I just need to put a few more, I'll probably put screws there. These are those plastic things. Let me put the side on. And so also in these cases, I don't know if I showed this already, but I put a simple filter, cut a hole where the CPU goes, and put one of these simple filters in. It's just riveted. I sprayed it black. Because you want some heat escaping on the back of the processor, and I wanted it filtered. Now, I've already showed, I think, that these are already filtered, but they're really hard to get to, so I made one extra filter, which is just some simple, I sprayed it, right? It's like a gunmetal. And you can get this at Depot. It's just a kind of a corrugated, perforated, and it sort of clips on here, but that's on there. It's not going anywhere. And believe me, that catches a lot. And this I got from something, I don't remember what the hell is that from. It's just helped me pull it off. Audi, it's a keychain thing. But yeah, it's just that simple. And just make sure it's in there. Let's go put it in. All right, she's all up and running. And right here on the device manager. Okay, and I'll toggle between them. I didn't plug the speakers in yet because I'm still using the Realtek.
Tomorrow.
So I'm running a PC Mark overclock test. This is just a gaming benchmark test, one of the many. And so that's up on this monitor. Now you can't touch the screen. You'll cancel the test. So you can't run any other screen capture program. And over here I have hardware monitors set up. And what I'm looking at is, well, in general, CPU core, right? And over here, I don't know if it'll focus in on it, but it's averaging about 40 degrees, 104 degrees Fahrenheit, 40 degrees C. That seems to be where it wants to be. Processor loading is, anywhere from 89 to 100%, depending on what's going on. Megahertz is ranging between 4066 to 4192. So it's sustained, okay? It's not really a turbo on these things because you can actually, when the demand is high, it will maintain on all cores the clock that you set. Now, you can have it set to have it run one core more than the others or some combination. But you can see just here in the powers, it's 83, 84 watts, 72 to 73 watts, 13, 14 watts, right? This is on the different power tap areas on the motherboard. This is part of the testing process. Make sure that the power supply is doing okay. Make sure the motherboard is all right, right? After you see some maybe potential damage on it, or you may feel there might be something wrong, you want to run something. And I'm going to run a number of other tests as well. That was now years ago because this is now 2026. Everything is working very good. I've been continuing to upgrade the computer. We'll go through that. Like I said, I put a 12 core in. I put some different stuff in here. It's got 64 gigs of DDR3 RAM, so it's lacking there. With the Intel 12-core server processor, video editing is got very smooth, very quick. So it runs pretty good. Now, a lot of that has to do with the NVMEs and the total amount of RAM. And video card will be coming soon, a small upgrade to like a 2070 Ti or something. Right now, and even at the time, I didn't have a donor rig laying around that I could test with and risk blowing up or having instability issues and saying, oh, that power supply really is bad. I've been having it running for a week now and it just keeps doing it. I don't know. All right, off it goes. So as you can see here, I'm running some, Heaven benchmarks, and I also ran FugeMark and a few others, and just to test for stability. At that time, everything was going good, and since then, like I say, I've done some other upgrades. So stability issues were probably related to this power supply, but then there's that connector, which the connector worked fine, and it didn't blammo anything right away. I checked it, as I mentioned again. Make sure you check all that stuff if you're going to make up custom cables. And if you don't know, just use the cables that come with your new power supply. So what happened? Well, with the 6-core processor, I was overclocking for years. I do overclock now, but the black processors were unlocked. And as I mentioned, you do need a little bit more voltage to really get that processor to rock and roll. Intel's got some weird idiosyncrasies, as we know. In that case, I need a little bit to wet it with a little bit more voltage going in. And then, of course, if you want a higher overclock at the clock speeds, I was running it at over 4 gig. I think that weighed on it. And subsequent to that, I made up another cable. I'm not showing it here, but it goes around to the bottom Molex connectors, and it supplies additional power to the PCIe rails. And now that I've completely filled those rails, all the sockets, I'm glad I did. So powering this, there's a few locations where you can add additional power. And I think if you're going to use these motherboards the way I'm using it, and the way many of you may be using it, you want to consider however you can get power, whether it's Molex, which is old school, or a SATA style, or whatever it is that you've got on your motherboard. You want to make sure that you're supplying the motherboard appropriately. If you don't, you could also burn out the motherboard. I've had high-end ROG Asus motherboards before. I'll see you guys in the future. There'll be more videos out on this, and hopefully this one was helpful. Everything is going pretty good, and we'll get to some more of the videos soon. I'll see you guys then. Check out the folder for that on my new channel. Hopefully years from now, you'll watch this again, and it won't be a new channel anymore. Thanks for watching this episode of It's AG, Archer's Garage Tech, so it's AG-T or AG-T&A.